The universe is expanding, but expanding into what? The farther a galaxy is, the faster it moves away from us. We call this cosmic expansion, and it's one of the most fundamental observations in modern cosmology. But here's the question. If space is expanding, where exactly is it expanding into? Is there an edge, a boundary? And why do we see a cosmic horizon beyond which we can never observe? Some physicists propose an answer so radical that it redefines our place in the cosmos. Our universe is not expanding into empty space. It's expanding inside a black hole. What exactly is a black hole? To understand this idea, let's break down what a black hole actually is. A black hole forms when a massive star collapses under its own gravity, compressing all its mass into a single point, what we call a singularity. This singularity is surrounded by an event horizon, the point of no return. Anything that crosses it is trapped forever, because escaping would require moving faster than light, which is impossible. But what's inside? General relativity tells us that, past the event horizon, space and time are no longer what we think they are. In fact, space itself is falling inward at the speed of light. To an external observer, nothing ever seems to pass through the event horizon. Objects falling in appear frozen in time, redshifting into darkness as their light stretches to infinity. But from the perspective of the infalling object, time continues normally. This leads us to the mind-bending idea. What if, from our perspective inside this universe, we are also inside an event horizon, one that we can't escape because it defines the very limits of our observable reality? The black hole universe hypothesis. Some physicists propose that when a black hole forms, it doesn't just collapse into nothingness. Instead, it might create a new, self-contained region of spacetime on the other side of its event horizon. From the outside, a black hole appears as a sphere in space, but inside, it could contain an entire universe. This idea isn't just speculation, it comes from the mathematics of Einstein's field equations. Some solutions describe black holes as wormholes to other regions of spacetime, possibly birthing new universes beyond our own. And here's where it gets interesting. The conditions inside a black hole's event horizon share surprising similarities with our own universe. Clue number 1. Cosmic expansion behaves like the interior of a black hole. Inside a black hole, spacetime isn't static. It stretches. The singularity at the center isn't necessarily a point in space but a moment in time, a future that everything is inevitably moving toward. Now compare this to our universe. The Big Bang wasn't an explosion in space, it was an expansion of space. Every galaxy is moving away from every other galaxy because the fabric of spacetime itself is stretching. This is exactly what we'd expect if we were inside the event horizon of a black hole. From our perspective, everything appears to be expanding, but in reality, we might simply be falling deeper into a singularity in a higher dimensional space. Clue 2. The cosmic microwave background and event horizons. In our universe, we have a visible boundary, the cosmic microwave background CMB. The CMB is the afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. Beyond this, we cannot see. Why? Because the universe was opaque before that time. The light from earlier epochs hasn't had enough time to reach us. But this limitation sounds eerily similar to something else, the event horizon of a black hole. Just as an event horizon marks the boundary beyond which no information escapes, the CMB marks the boundary beyond which we cannot receive information. If we are inside a black hole, then the CMB might not be the true edge of the universe, just the furthest light we can ever hope to observe, limited by the curvature of spacetime within our cosmic event horizon. Clue 3. The nature of singularities. In a traditional black hole, all matter is thought to collapse into a singularity, a point of infinite density. But some models suggest that instead of a true singularity, a black hole might create a bounce, an event where extreme conditions generate a new expanding universe on the other side of the event horizon. In other words, the Big Bang might not have been the beginning of everything, but rather the moment our black hole bounced into existence within a larger parent universe. This could mean that every black hole in our universe is actually a gateway to a new universe, each with its own space-time, its own physics, and possibly even its own laws of nature. What would this mean? If this hypothesis is correct, then our universe is just one of an infinite number of universes, each contained within its own black hole, nested within a larger multiverse. And this would imply that every black hole we observe in our universe might itself be a cosmic womb, birthing entirely new universes beyond our reach. This could explain why the fundamental constants of our universe, like the strength of gravity, the speed of light, and the mass of fundamental particles, seem finely tuned for life. If each black hole spawns a new universe with slightly different physical laws, then natural selection might apply on a cosmic scale. Universes that produce more black holes lead to more offspring universes, evolving a multiverse bias toward those that can sustain complex structures. Final thoughts. Could this really be true? Right now, this is a fascinating but unproven idea. We don't yet have direct evidence that black holes create new universes, nor that we are inside one. But the mathematical parallels between black hole interiors and the large-scale structure of our universe suggest this is more than just science fiction. If true, this would fundamentally reshape our understanding of reality. Instead of a single, isolated cosmos, we would be part of a vast, interconnected web of universes, each emerging from the depths of another. So, are we inside a black hole? We don't know for sure, but the evidence suggests that it's a question worth taking seriously.